Hey, welcome back, Algebra. I hope that test went pretty well for you. But here we go. It's lesson 37, page 149. We're going to talk about inequalities first, and we're going to move on to some other stuff. When we talk about inequalities, we're talking about three symbols. We're talking about not equal to and greater than and less than symbols. We could describe lots of ways to do an equality. 4 is not equal to 5, right? 4 is greater than 2. We could say 4 is greater than or equal to 2 plus 2. Or 2 plus 2 is less than or equal to 4. We can read things lots of different ways, and that didn't look so good because I wrote it without looking at the board, and that's probably not a good idea for me to do. So, inequalities can be false inequalities, true, or conditional, and that's what we are going to talk about. 4 plus 2 less than or equal to 3. Is that a true, false, or conditional equality? And the answer is that should be definitely false, because in no situation is 4 plus 2 less than or equal to 3. So, false. How about x plus 2 is greater than or equal to x? That is true. It's a statement, because if we're talking about the exact same number and we're adding 2 to one of them, that's going to be greater than or equal to it. So we could say that that's a true statement. Now, this one, x is less than 4. Is that true or false? The answer is, I don't know. It depends on what x is going to be. So this is a conditional inequality. X is less than 4. If a number that we use as a replacement for a variable makes the inequality a true inequality, then we say the solution for the inequality and say that the number for x will satisfy the inequality. Okay, so when we're talking about a set of numbers, we call it the solution set. So let's take a look at some of those and let's see what we got here. I'm going to draw one number line, and I'm going to use different colors to represent different things on this number line. Okay, so I might be erasing stuff as I do this. So I'm going to kind of write, instead of everything on the line, I'm going to write everything above the line. Alright, I have all my numbers written out. Okay, so let's take a look at my number line, and I know it's not very straight, and I apologize for that. 0 is a real number and can be used to describe a distance of 0. Any other number that can be used to describe a physical distance is a positive real number. Positive numbers are talking about physical distances, and the opposite of each of these numbers is a negative real number. We use the number line to help us picture the way real numbers are ordered, okay? And to help us to define what we mean by greater than, because that's what we're talking about on this number line. We have graphed 2 and 4. And I said I was going to write these above it. 2 and 4. We remember the number is greater than another number if it's to the right of the other numbers. 4 is greater than 2 because it's to the right of 2. And that's using the same definition, we could say that negative 1, I'm going to use a different color, we could say that negative 1 is greater than negative 4 because negative 1 is to the right of the number. So that's why number lines work so nicely. So keep that in mind as we go into the next section. I'm going to erase these, and let's move on to the next section. And I'll try to use different colors for this. But what we're going to do is we're going to draw a number line in graph. I've got the number line right there. The solution x is greater than 2. Okay, so can x be 2? No, it can't, because it said greater than 2. So I'm going to draw an open circle above the 2. Open showing that it's not going to be 2. It's going to be greater than, so I'm going to draw an arrow to the right, showing it's going to represent a number that's bigger than 2. What the number is, I don't know. We're not going to try to solve that. Okay, but hopefully that is clear to you. Let's try a couple more. I'll use a different color to separate out what I'm doing. And let's try another one. Let's change the pen. That's always useful to do. How about x is less than or equal to 2? So now I'm saying x can be 2 because I said equal. But it's also going to be less than 2. So now 2 is going to get a closed circle. And I said less than, so we're going to draw an arrow to the left. And I'm just going to go all the way across the number line. What x happens to be, I don't know. I'm just trying to represent that x is less than or equal to 2. Okay? So far, not too hard. This time I'm going to draw a graph and we're going to write an inequality. Do a different color. All right, we don't know what number we're talking about, so that's going to be x. X is going to represent that variable. And x is going to represent a number for us. Can x be negative 3? And the answer is no, because I used an open circle. So x is less than negative 3. What x is, again, I don't know. I'm not interested in that. I'm interested in graphing it. As long as I can show that x is definitely not negative 3, and x is less than it, I'm doing this problem right. And that's all I have for you today. So nice work. Try A and B on page 151. We'll talk tomorrow a little bit, and have a good day.